Gibbs again. I've been with SSERVI for about a year, and I'm really enjoying learning about all of the amazing research that you're all doing. It is definitely a new field for me, but it's an amazing field, and I echo much of what Addie said about the community. It's a really amazing community. I come from a different group, and I can see and feel the differences and the collaboration and the working together and support that everybody gives. So without further ado, it's my honor to award the second Susan Mahan Niebuhr Award for Early Career, and that is for Dr. Samuel J. Lawrence. So I have just a couple things to say about you, and then I'll turn over the microphone to you. But Dr. Lawrence received his bachelor's degree from the University of Michigan in 2000. He went on to the University of Hawaii in Manoa and then continued postdoctorate research at Arizona State University. I think they liked him very much as well because he stayed on there to do some faculty research and become an assistant research professor. He is now at the Johnson Space Center as a planetary scientist. His current research focus on investigating composition, origin, and evolution of planetary surfaces by integrating petrology with remote sensing. He also works to improve planetary spatial infrastructure tools and performs applied exploration science enabling U.S. spaceflight human goals. As a co-investigator of the Lunar Reconnaissance Orbiter Camera Instrument Team, Dr. Lawrence draws from a wide range of data from the LRO mission to understand lunar volcanic processes and the thermal history of the moon. He is also very much an advocate for this community with policymakers and the like. He, one of the nominators noted that he has a deep understanding of the interwoven nature of exploration and science and has brought an active role in defining future goals and current knowledge gaps. And so, again, working towards the expansion of this community. And to that end, he is in many different organizations, and I'll list a few of the highlights here. He is the Emeritus Chair for the NASA US and GS Mapping and Planetary Infrastructure Team, and he was doing that for 4 years. He is the Vice Chair currently for League and will become the Chair in March of 2018. And he was recently appointed the Curation and Analysis Planning Team for Extraterrestrial Materials as the Informatics Chair. And lastly, he represents the planetary cartography community on the Planetary Science Subcommittee of the NAC. And this is until this year.
Yeah, until it's disbanded.
Oh, okay. Well, sorry, I wasn't aware of that. And also, importantly for this, is he has mentored numerous students seeking careers in the planetary and exploration sciences and continuing to promote the equal opportunity participation within this community. And I'll close with the fun fact that you shared with us. Almost to the day, today, 8 years ago, was his first talk at the forum. It was his 4th public talk, and he was able to share about the LROC first light. And so, long way from 8 years ago, but we welcome you and congratulate you.
Well, thank you, Christina. It is a distinct honor to be here, and it's particularly humbling to be receiving the Susan Niebur Award. I met Susan once at one of her legendary proposal writing workshops where she led by example, leading with compassion and empathy and setting a good model for us all to emulate as we strive to increase the diversity and inclusiveness of our field. Dr. Pendleton asked me to talk a little bit about my own experiences as an early career researcher and offer some advice on how early career researchers can be developed into strong leaders of our community. So let's see here. Next slide, please. There we go. So my story begins when I watched the first launch of the Space Shuttle Columbia in 1981. And watching that shuttle launch, something crystallized. I knew that space was going to be the defining focus of my life. And I'll make here the same point I made at the Vision 2050 meeting, that it's important to remember that the space shuttle wasn't just a launch vehicle. It was the tool that was going to be used by the United States to open the space frontier for the entire human race and make the visions of folks like Jerry O'Neill a reality. And unfortunately, things didn't quite turn out the way we had hoped, but as a kid, I didn't really fully appreciate that. Next slide, please. So my parents did everything they possibly could to nurture my interest in science and technology. I'm pretty sure, in fact, I'm positive, that they checked out every book about space at the Detroit Public Library System 2 or 3 times. And in one of those books, there were some blueprints of the shuttle cockpit, so I used some magic markers and a couple of cardboard boxes. I made a reasonably high fidelity 1G trainer. And then my sister and I, who was a really good sport, used to simulate NASA missions using space shuttle launch procedures. And so it always seemed like I was going to be an aerospace engineer. Next slide, please. And then in 1992, the Space Exploration Initiative was ongoing, and I read this fantastic article in Air and Space magazine by Angie Chaikin about the value of a lunar base. And it featured a lot of interviews with this guy named Wendell Mindell. And I remember reading this in the 90s, going, you know, this Wendell Mindell guy, boy, he makes good sense. I'm pretty sure he's right. And also, he has a really cool job. And if I'm really lucky, someday I might have a job as cool as Wendell Mindell's. And little did I know. In the late 1990s, the discovery of potential biosignatures in ALH 84001 hit the headlines, and that brought planetary science and cosmochemistry into the public consciousness. And so I decided to change course slightly, and especially after I read Don Wilhelms's epic book, To a Rocky Moon, and I decided that that it was pretty clear that finding the resources necessary to sustain human settlement was going to be one of the big questions of the 21st century. So I changed course slightly and became a geologist. Next slide, please. After a brief stint in private industry, I was picked up in 2002 by Jeff Taylor at the University of Hawaii, and I was originally brought on board to do Mars Odyssey data analysis. And then a couple of things happened. I met this interesting fellow named, this guy right here, named B. Ray Hawk. We worked similar hours in the data center. We got along really well. He became a close friend of myself and my wife. And B. Ray kept telling me, you know, there's a lot of work left to be done on the moon. We still haven't figured it all out yet. And then later on, for the second time in my life, in 2004, President Bush announced that we were going to go back to the moon and use the resources we found there to enable longer voyages to Mars and beyond. And I decided to switch course from Mars to lunar studies because I decided I was going to do everything I possibly could to help the vision for space exploration succeed. And as it happened, through sheer, pure dumb luck, Jeff Taylor was the first league chair. And Jeff worked very hard to a degree that I'm only now beginning to appreciate now that I've been an AG chair and I'm about to take over league, just how hard Jeff worked to make sure I had opportunities to participate in the early years of the vision. He got me to the first league meeting in 2005, and he gave me a chance to participate in some of the special action teams that helped define the science goals for lunar exploration. And at one of those special action teams, I met one Mike Wargo, and I remember and this would have been in 2005, and Mike, he was just so excited that a graduate student was there. He was so enthusiastic that someone so young was enthusiastically participating in what some might describe as a fairly boring activity. But Mike said that, you know, it's people my age who can get the ball rolling, but it's going to be up to you to finish the job, and that kind of stuck with me. As one of those special action teams, we produced this fine spreadsheet, seen over my left and right shoulders, complete in all of its Office 2007 beta glory, the themes, objectives, and phasing spreadsheet for lunar exploration. And as it happened, Jeff and Steve Mackwell and I wound up being the editors of this document. I remember staying up for more or less 3 days straight to make sure we got it to Mike on time. And this document formed the nucleus for the current lunar exploration roadmap. And if I'm going to just soapbox here for a little minute, the fact that this document, which was produced through an inclusive bottoms-up community process, and clearly showed the clear value of a lunar base to the American people and the scientific community, somehow got the name the spreadsheet of death, when in fact it showed all the amazing things you could do on the lunar surface, was, in my view, kind of a bad move. But the other point I wanted to make, and this is my advice for the early career researchers and their advisors, is that it is so important to get students involved in the advisory groups. It's important to get and be involved in strategic planning. Send your PhD students to AG meetings. You know, it's how you develop the network that you use to be successful in this career. I didn't know it then, but it has become apparent that my participation in these special action teams more or less defined my career. So first of all, Jeff, I retroactively appreciate you more than I already did. But it is so important to get students involved, and that's why to this day, League still sponsors, along with our close friends at SSERVI, the B. Ray Hawk Next Lunar Generation Career Development Award, to make sure we can develop the strong generation of leaders that we need to finish the job. Next slide, please. So after graduate school, I had a fairly tough time. I had quite a few different offers. Ultimately decided to pick the one from Mark Robinson to work in the LROC science team at Arizona State. And it was supposed to be a 2-year stint. It wound up being over 8 years, and clearly pretty sure I made the right call. So after a lot of hard work, you know, we were ready to launch almost, you know, in 2009. After a couple years of effort, we were finally ready to launch. I remember my good friend Noah Petro was telling me, you know, this could be the last time an American spacecraft is not orbiting the moon. So you should keep a diary, record your thoughts, your feelings, so you can remember what it was like in those during the launch time. And Noah, I have to say, I totally should have done that. I didn't do that. I probably should have. You were right. But the one thing I do remember is the incredible enthusiasm and the excitement. We were finally moving beyond PowerPoint slides to take concrete steps to return the United States to its rightful place on the surface of the moon. And it was just incredibly exciting. And then after the rocket launched with LRO and LCROSS aboard, we literally hopped right on an aircraft and started flying back to ASU to start commissioning our instrument. And most of that happened, on my left here is the first image from Heli Crater that came down on June 30th with the LROC instrument. And let me tell you, there is no better way to celebrate the 4th of July than by commissioning an American spacecraft in lunar orbit. I highly recommend it. That is the absolute best way to celebrate the 4th of July. And ever since that point, next slide please, after 8 years in lunar orbit, I think it's safe to say that LRO, along with the other missions in lunar orbit that have been to the moon during this renaissance sparked by the vision, you know, Grail and Lottie, and all of our international partner missions, I think it's safe to say that we've redefined every single paradigm we once had about the moon. From the diversity of lunar volcanic processes, to recent lunar tectonism, to the fact we don't understand solar system chronology nearly as well as we thought we did, to surface processes, to new details about the impact cratering rate and how impact cratering works, to the moon's vast resource potential. I think we now know that the moon is a far more interesting and far more valuable destination for future exploration than we ever thought during even the Apollo years. And I think the fact we were able to observe and report on what our Chinese colleagues were doing on the surface of the moon with the Chang'e 3 mission shows our way to a future where LRO is continuing to do fantastic science, but we're also enabling surface exploration, much like MRO does for the Mars rovers. And it's my fondest hope, although it's perhaps less likely than it was several years ago, that LRO will still be functioning in an orbit when the next American steps onto the surface are taken. And it's also a good thing to point out that the mission's not complete yet. LRO still has fuel for many more years of operations, and as we speak, the members of the LRO science team are diligently preparing for the follow-up to the Cornerstone mission. As B-Ray once said, there's still a lot of work left to be done. So let's talk a little bit about the future. Next slide, please. For the past several decades, we've heard a lot about the hunt for life on other planets. And that's certainly an important question, but it's not the only important question. In my opinion, hit next please. The question of can we extend human life to settlements in other worlds is every bit as important as can we find life on other worlds. The answer to that question will define our future as a nation and our destiny as a species. It is the answer to that question that will define whether we face a future of scarcity and decline or a future of freedom and opportunity and prosperity. And it's the people in this room and watching online who hold that destiny in their hands. We are the trailblazers. We are the people who begin to answer this question. And we will answer that question on the moon. Next slide, please. The moon is where we will turn other planets from a wilderness, visited only briefly and tentatively, to a frontier of human activity. With its vast resource potential and compelling science questions, returning humans and robots to the surface of the moon will result in quantum advances in planetary science. And next slide, please. And perhaps most importantly, provide enduring opportunities for commercial activity. Now, I started out as a skeptic about commercial activity on the moon, but I have now become cautiously enthusiastic at the opportunities provided by the emerging commercial providers. And I am optimistic enough to think that if we can work together and develop how public-private partnerships will work and increase the flight rate and make sure we get to the moon more frequently with rovers and landers and sample return missions, we will make great science advances. Now, it's not going to be easy. It might be awkward as two very different technical cultures collide in unpredictable ways, but it will be worth it because there's a lot of missions out there and there's a lot of instruments out there that deserve a chance to fly. And the moon is where we can fly them and do those experiments and fly those missions and make great advances. So next slide, please. So the moon is not a distraction. It's not a detour. It's not the destination that keeps you from going to other places in the solar system. It's the critical enabling asset for everything we want to do in space. It's the cornerstone of the solar system. And when I look at the future, I'm not just trying to say, well, how do we enable Mars exploration? It's also how do we get people to Ceres? How do we get to Ganymede? How do we get to destinations beyond? And the moon is how you do that. Next slide, please. The moon is a world full of wonder and opportunity. Opportunity for science, opportunity for commerce, opportunity for exploration. It's only a few days away, and it's waiting for us to explore it. So, in a lot of different ways, I kind of feel like I'm getting this award now for things I haven't quite managed to pull off yet. But I am absolutely confident that despite all the challenges that we face, we will work together and overcome them. And as those who know me well can attest, my own personal victory condition is that I aim to see the day when I can go with my wife and my family to the Smithsonian Institution's Tranquility Base Annex and buy hats and t-shirts. And that's the point I can say, yeah, okay, I'm done. Because that means we'll have succeeded. And with every living fiber of my being, I'm absolutely optimistic that the very best is yet to come. So thank you very much, and I'm looking forward to working with you to make this vision a reality.